Hello everyone, today we are going to talk about the TCP three-way handshake. We previously mentioned that TCP is a reliable transmission protocol. So how does it ensure reliable transmission? It does so by establishing a connection before transmitting data. Now, how is this connection established? It is done through the TCP three-way handshake. Before we dive into the connection process, let's recall what we discussed in the last class. In the last class, we talked about the sequence number, SEQ, and the acknowledgement, ACK. Here, we refer to ACK as the acknowledgement number, and among the control bits, there are three, one of which is also called ACK, but this one is referred to as the ACK acknowledgement bit. Only this acknowledgement bit. The flag being set to 1 indicates that this acknowledgement number is meaningful, meaning this acknowledgement bit shows whether you have enabled the acknowledgement function. If the function is enabled, it is 1. If not, it is 0. Once enabled, only then does the acknowledgement number have meaning. If the acknowledgement function is not enabled, then the acknowledgement number is meaningless. Besides this, there is also a SYN, which is called the synchronization bit, and FIN, which is called the finish bit. Now that you know these, we can talk about our three-way handshake. Suppose now that my PC1 here wants to access the 23 port of PC2, meaning I want to perform remote control on it. First, I need to use my own IP along with a port number. So to access the other party's IP and port number, that's HCIE. My own source port number is a randomly generated high port number, while the 23 here is the destination port. The destination port is a fixed well-known port. 23 is for Telnet. Now let's mainly look at the process between them. First, let's look at this. Here, we will specify who we are coming from and who we want to access. Now let's look at the TCP header. It has an SEQ sequence number, and besides SEQ, there is also an ACK, which is our acknowledgement number. In this section, there is only one flag bit. What does the SYN flag mean, Mia? This is actually very simple. Let me give you an example. Suppose you see a handsome guy or a beautiful girl on the street who really catches your eye. You want to go up and introduce yourself, The SYN flag is like saying, I want to sync with you, I want to get to know you. So in this context, the SYN is set. Then, if the person hears you and also wants to be friends, they might respond with, sure. This is where the ACK comes in, which functions as an acknowledgement, confirming that they heard what you said. Then they might say, let's be friends. So they also send you a signal indicating they want to sync with you. SYN, and here it is, so in. And the ACK is set. Here, the SEQ at the beginning or is random for both. Later, to represent reliability. How do we demonstrate reliability? I need to confirm. How do I confirm that I received your message? I will take the other party's sequence number and add one as an acknowledgement. So here, the ACK uses the other party's sequence number, meaning A plus 1 as an acknowledgement. At the same time, what do you tell the other party? Next time, if you receive my message, then you use this A plus 1 as your sequence number. So here we can see that when my PC1 replies to PC2, I use the other party's ACK. In this case, my ACK also needs to confirm that I received the previous message's reply. So I take their sequence number and add 1, which is B plus 1 here as well. I say to the other person, let's get to know each other, and they say, sure, let's get to know each other. I say, great, great. So here, I also need to send an ACK, but do I still need to? No, it's not necessary, y'all. It's like two people falling in love. One person has already said, let's be together, and the other says, okay, let's be together. You say that's great. But would you still ask them, shall we be together again? Certainly not, because you are already together. In this context, we say that the overall acknowledgement mechanism is the ACK. What will I use for this acknowledgement number? I will use the sequence number given by the other party previously. Add one later, I'm here. What am I? I am a, so in this context, I am a +1 to confirm that I received your message, Huang. At the same time, this ACK will also inform the other party that in the future, you should use this ACK I gave you as confirmation, confirming that you received my message. In this context, the SEQ will use the previous ACK given by the other party as a filler. At the beginning, ACK1 starts and this ACK has no meaning. In this context, when I first get to know someone, do I need to confirm with them? I don't need to confirm with them. I just need to express that I want to synchronize with them, that I want to get to know them. However, in this context, I can't just directly say, okay, let's get to know each other. I agreed. But agreed to what? The other person hasn't said anything yet. So, in this context, we say the ACK confirmation bit is not enabled. This confirmation function is not activated. So, in this context, what is ACK? It actually has no meaning. Until my confirmation is enabled, only then does my confirmation become meaningful. My ACK will use the other party's SEQ plus 1, which equals the other party's SEQ plus 1. In this context, SEQ will use the ACK provided by the other party as a filler. Here, both of our initial SEQs are random, and afterwards they will follow this principle, meaning the SEQ will use the other parties. Regarding this ACK, if during this process PCE sends data to PC2, why does the value of the acknowledgement number field not increase in the segment sent by PC1? Here, I might send a lot of data at once and I don't need the other party to acknowledge each one individually. I can send multiple segments and let the receiver acknowledge them collectively. In this case, I first sent an A plus 1. The ACK, it's B plus E. The data is 12 bytes, so when the other party acknowledges it now, what is the sequence number? The sequence number is used to prove that I have received it with the other party's ACK, so it's B plus 1. At this point, the acknowledgement is. You need to use this SEQ plus its data to tell it that I have received by it, so it's a plus 1 plus 12. Then the other party's SEQ proves that I have received it using the other party's ACK, so it's a plus 13. Here, the ACK is used to confirm that I have received the other party's data. So we use the other party's SEQ, and here, we talk about the effective transmission of data. Here, he sent me 66 bytes of data again. In this case, my sequence number to represent acknowledgement should use the other party's ACKB plus 1. For the ACK, I need to use the other party's sequence number plus this data, which means a plus 13 plus 66. So, in this context, the sender can send multiple data segments at once, and we can collectively receive them to make a single acknowledgement. In this context, can we say that PC1 can send any amount of data to PC2? Actually, that's not the case. During the TCP three-way handshake, both parties will use the window field to inform each other of the maximum number of bytes they can receive locally, or in other words, don't send too much, or I won't be able to store it here. So in this process, after the connection is established, the sender will send only the amount specified by the receiver. For example, if the receiver says 3, then the sender will only send 3. After receiving the data, the receiver will place it into its buffer and wait for an upper layer application to retrieve this buffered data. Once the data is retrieved by the upper layer application, the corresponding buffer will be released. For example, initially I receive 1, then 2, then 3, and then it's full and I can't receive anymore. When 1 is taken away, the data is retrieved and I release 1. After releasing 1, the receiver will notify the sender based on the buffer size, indicating the size of data it can receive. Then the sender will send a certain amount of data based on the current window size of the receiver. So, in this process, everything is actually dependent on the receiver. Eventually, there comes a moment when we say the data has been completely transmitted. After the transmission is complete, we need to close the connection, which involves our TCP. The four-way handshake will be explained in the next lesson. If anyone wants to learn about Huawei certification technology, or obtain the Huawei certification question bank, please send me a private message, or you can leave more comments below the video.